Now in this video, I've got the PNP 8550 transistor AC amplifier circuit. I will have a collector resistor, a resistor coming off the base, a second resistor coming off the base to ground, and an emitter resistor. On the input side, I'm going to have a 1 volt peak-to-peak sinusoidal input. The frequency will be 1 kilohertz in series with a 22 microfarad capacitor. Across the front of the transistor, I've got a 10 volt DC source. The idea is that I input the 1 volt peak-to-peak sinusoidal, and on the output side, I get a much bigger sinusoidal. But in order for that to happen, the transistor will have to be properly biased. I'm going to want 5 volts across the collector resistor. I'm going to want 1 volt across the emitter resistor and 4 volts across the collector emitter. My current will be 10 milliamps. So 10 milliamps will be flowing through the collector resistor, and 10 milliamps will also be flowing through the emitter resistor. Now the value of my collector resistor equals 5 volts divided by 10 milliamps. 5 volts divided by 10 milliamps, that gives me 500 ohms. And the value of my emitter resistor will be RE equals 1 volt divided by 10 milliamps. That equals 1 volt divided by 10 milliamps. That gives me a value of 100 ohms. Now I will find the value of my base resistor. Now, since I will be having 10 milliamps coming down here and flowing through the base emitter junction, I'm going to have a voltage drop somewhere around 0.7 volts. So the voltage across my base resistor, I'm going to call it VVR, the voltage will be 10 volts minus the sum of 1 volt and 0.7 volts. So that will be 10 volts minus 1.7 volts. That gives me the voltage across my base resistor of 8.3 volts. the beta of my transistor equals 300. I'm going to use that beta and find my base current. IB equals 10 milliamps divided by a beta of 300. That equals 10 milliamps divided by 300. That equals a base current of 33.3 microamps. IB equals 33.3 microamps. Now, I'm going to take that 33.3 microamps and I'm going to multiply that by 10. .3 microamps times 10, that equals 333 microamps. So now I'm going to have a current of 333 microamps flowing through my base resistor. Now, I'm going to use this voltage and this current in order to find the value of my base resistor. So RB equals 8.3 volts divided by 333 microamps. That will give me a value of about 25 ohms. Now, I'm going to take my 33.3 microamps of base current, and I'm going to multiply that by 9, and that current will be the current I have going through this resistor. .3 microamps times 9 equals 33.3 microamps times 9. That equals a value of about 300 it's approximately 300 microamps. So this current equals about 300 microamps. The voltage is 1.7 volts. So the voltage across this resistor is 1.7 volts, and it's the same voltage across VBE and my emitter resistor. Now I'm going to use this voltage and this current and find the value of this resistor. I'm going to call this this one my R1 resistor. This one I'm going to call it R2. So I'm going to go R2 equals 1.7 volts divided by 300 microamps. .7 volts divided by 300 microamps. And that gives me a value of about 5.7 k ohms. Now, in order for me to find out exactly the amount of voltage that will appear right here because of the input, I'm gonna have to know what the voltage gain is. And the voltage gain equals AV equals 500 ohms divided by 102.6 ohms. Now, that 102.6 ohms is this resistance plus an extra resistance of 2.6 ohms. Now, where did I get 2.6 ohms from? I used my thermal voltage of 26 millivolts and divided that by my 10 milliamp current. And that gives me 2.6 volts.